Good afternoon everyone and welcome to another video on Mr. Ong Maths Lesson. Hope everyone is feeling safe. We are now on the 6th day of the national lockdown and hopefully you guys are practicing hard for your coming exam as well as the NCEA exam at the end of the year. So today we are looking at probability. We are looking at how to calculate probability from tables. Okay, this is a common question in the year 9, year 10, as well as the NCEA Level 1 and Level 2 exam. Okay, so without further ado, let's go. So the first question is from the 2019 NCEA Chance and Data Level 1 exam, and we shall read the question. Okay, the table shows minor injuries that were reported in different sports during the 2018 within New Zealand. For a random sample of 300 sports players, this was recorded by gender, so male and female, and there are 4 sports: rugby, netball, cricket, and football. So this is a 2x2 table, contingency table. And the first thing you do in a contingency table, you have to calculate the row total as well as the column total. So we have calculated. So for female, we calculate 20 plus 60 plus 15 plus 10, and the row total is 105 for female, and for male, it's going to do the same thing. It's going to be 195. So you add the two numbers, they add up to 300 because they tell you that the total number of people are 300. Similarly, for column total, for rugby, just add the male and female. 20 plus 70 is 90, 60 and 30 is 90, 15 and 25 is 40, 10 and 70 is 80, and the row total is also 300, okay? So make sure you either add the row total or the column total, and they will give you 300 in total, okay? So once we have that data, we can actually calculate the probability. Very simple, okay? So the first question is very straightforward, okay? So the question says, based on the figure, what is the probability that a player suffered a minor injury playing rugby? So a minor injury playing rugby is rugby here, so it's going to be, rugby is 90 out of the total, so it could be 90 out of 300. You can put in there, that will give you an achieve in NCEA Level 1 Chance and Data. Not too bad, right? Okay, so the second question, part 2, based on this figure, which sport had the had a higher chance of one of its male players suffering an injury? So very simple. So for rugby, okay, for the male players, it will be 70 out of 90. So they give you 0.777. For netball, it's 30 out of 90. So give you 0.333. We're looking at the male. For cricket, 25 out of 40. It's going to be 0.625. And football is 70 out of 80. Is 0.875. So we have to answer the question. Based on the figure, which sport has the highest chance of one of its male players suffering a major injury? The answer is when they are playing football. If you can answer that, that is the merit in NCEA Level 1 for Chance and Data. Okay? So we shall do the following year, the 2020 exam, which was last year's exam. And let's go. Okay? So we read the question again. The table shows a random sample of 1,350 birds, okay, on Stewart Island during the 2019 that either moved away or stayed away. So they either move away or stayed, and they are recorded by gender, female and male, okay? So the total is 1350. So the total here, 1350, is the total of number of birds, okay? So this time, the row totals have been calculated, and the column total has also been calculated. So you don't have to do anything, okay? So once you have the table, need to answer the question, okay? One of the bird was selected. What is the probability that the female who stayed? So female who stayed is going to be this number here. So 165 out of the total. So 165 over 1350, and the answer is 0.1222, and that will give you a simple achieve. Okay, next one. One of the birds that stayed was selected. So we are looking at those who stayed, okay? Only those who stayed. What is the probability that the male? So it's going to be 85 out of 250 because only we're looking at the state bird. So 85 out of 250, and the answer is 0.34, and that will give you a merit. And last but not least, we look at The last question for NCEA Level 1 is it a male or female that is more likely to move away? So move away. So we're going to look at female who move away is going to be 690 that move away out of a total of 855 bird, and that gives you 0.8070. And for the male, it's going to be 410 out of the total male is 495, and the answer is 8283. And you need to answer the question, which is more likely to move away? So your answer is going to be male is more likely to move away. If you can answer that, that is a merit in NCEA Level 1 chance and data. Okay, great. Now we shall look at the question on Level 2. Level 2, the probability paper is called Probability Method, and we shall look at it now. Okay, Matthew analyzed Kaitaya's daily weather data from the NIWA for the last 7 years. He classified the day as windy if the mean or wind speed was above 36 kilometers per hour, and still it is otherwise. Okay, he classified the day as wet if more than 2 millimeters of rain fell, and dry otherwise. He summarized the analysis in the table below. So wet or dry, windy, and still. So again, the row total is given, the column total is given, so your job is done. Okay, so now we shall answer question 1, 2, and 3. Okay, it's very simple. What proportion of the days over this time were windy? So windy is going to be here. So it's going to be 1646 out of total number of days, 2556. And the answer, put in your calculator, is 0.644. And that will give you a simple achieve. Okay? Next one. What proportion of the wet days over time were still? Okay? What proportion of the wet days? So we are looking at wet days here. Okay? Were still. Okay? So still is going to be 88 out of 641. So the answer is 0.1373. And that will give you a merit. Okay? Quite straightforward, isn't it? Okay. Last but not least. Over this year, is it more likely to be wet on a windy day or wet on a still day? So we need to calculate the probability. So probability of wet when windy, okay? So wet when windy, so wet when windy is 553 over 1646 and come up to 0.36. Still, when windy, wet when it is a still day, so it's 88 out of 910 is 0.967. So this probability is bigger than that. So it is more likely to be wet when windy, and that will give you a merit. Okay? So it is more likely it to be more wet when windy. Got it? So great. So now we shall look at the last question. That is last year's NCEA. Okay? Probability method level 2 again. Okay, so let's go. Okay? An online survey in North America of EV owners, plug-in vehicle, and other interested people during a 3-month period in 2018. The results were summarized below. Either you have a home solar system or no solar system, and divided into EV, PHV, and non-electric vehicle. Okay, and the table is all calculated. The row total is calculated, and the column total is calculated, and the total number of people surveyed is 2,000. Okay, so once we have done that, we are going to answer the question. Okay, what proportion of survey respondents own on EV or PHEV? So that number and that number, you're going to add them up to 275 out of 2,000 plus 145 out of 2,000 and add them up, and the answer is 420 out of 2,000, or simplified in decimal form is 0.21, and that is an easy achieve in level 2. Okay, great. The next question is, what type of vehicle, either EV, PHV, or non-electric vehicle, is more likely to have a home solar system? So we are going to calculate that. So for the EV people, it's going to be 104 have home solar system. Our total of 275 will give you 0.3782. For the PHEV people, it's going to be 45. Our 145 will give you 0.3103. For the non-electric people, it's going to be 205 over 1580, and that will give you 0.1297. And again, you have to answer the question, which of them is more likely to have solar system. So you have to look at the highest probability, and again, the answer is the people with the electric vehicle will have a higher chances of a solar system than the other two categories, and the answer is going to be like electric vehicle people. So technically, we have done the probability using the table. Hopefully, you understand it. So keep on watching. Stay safe, everyone, and see you soon. Cheers, everyone.